keys. Zoinks.
9 and 11. Okay, we're recording. So we're going to finish up our notes on the quadratic story problems. And we are on number 9. It's kind of small to read.
Are you recording?
Yes, I already said that. You have a 1,200-foot roll of fencing and a large field. You want to make 2 paddocks by splitting a rectangular enclosure in half. So let's just stop there and draw a picture. So it's telling us we have a rectangular enclosure and that you are going to split it in half. So even if you've never seen the word paddock, it does explain to you they're just making 2 smaller fenced-in areas. What are the dimensions of the largest such enclosure? So if this was just a rectangle, we talked about previously that it would be a square, but now I have an extra line. So I have, we'll call this the width. I'm going to have 3 of those. And then all the way along here, let's call this length and length. So it's like a perimeter problem, but we've added an extra line. And we have 1,200 feet of fencing that's going to make all of this. So basically I have 2 lengths and 3 widths that are all going to go together out of the 1,200 foot roll. Then we're trying to find the area of this whole thing that's going to be maximum. Now, when I'm doing area, I don't care that there's an extra line through the middle. Area is still just length times width. So what I'm going to do with this is I'm going to rearrange this equation to either get L or W by itself and substitute it in here to make a quadratic, just like we did with number 8. So do you guys want to solve for L or W?
What?
Do you want to solve this for L or solve it for W?
L, because there's only 2.
L, because it doesn't matter. So we're going to subtract 3W from both sides. And so there's 2L equals 1,200 minus 3W.
So then you assume divide by 2.
Divide by 2. And so L equals, and I'm going to go ahead and divide both of these by 2. So it'd be 600 minus 1.5W. I'm just going to go ahead and use a decimal for that because it'll make the next part easier. So my area is length times width. What I'm going to do, all of this is the length. I'm going to substitute it for length in that formula up there. So my area then is going to be 600 minus 1.5W. I'm putting that in parentheses to group it, times the other W. So this is the length written in different terms times the width. And then we can distribute this out. And we know that we're trying to maximize this. So this is just the area. That's just the name of our function. It's our y.
600W minus 1.5W squared.
Yes, 600W minus 1.5W squared when we distribute both of those. And we usually see this the other way. So if you want to rearrange it and make it 1.5W squared plus 600W, you can. Because then you have them in the order that we're accustomed to. So if I'm going to maximize the area, this parabola opens down. We know that because this first term is negative. It's going to open up this way. So what we're doing is we're looking at a function that has width, and we are comparing it to total area. And there is a perfect width here in the middle that's going to have the biggest area possible, and we're trying to figure out what that is. So this is going to be the vertex. And to find vertex, we do the same thing every time, negative b over 2a. So our w, which is kind of our x value if we're thinking x coordinates, we're going to do negative b over 2a, which is negative 600, over 2 times negative 1.5. Now, make sure that you're multiplying these two numbers together first before you divide. So that'd be negative 600 over negative 3. Sorry. Okay? So the negatives cancel. What are we going to get? Negative 600 divided by negative 3.
Or sorry, 200.
200. So this perfect width right here that gets me that maximum is 200. So my width is 200. So if I go back to the picture, this is 200, this is 200, and this is 200. So that's going to be 600 out of the 1200 that I have. So I used half of it to go this way.
So the length would be 300.
So then the length should be 300 because, so basically what we're looking at, so we have 1200. We just used 600 of it up this way, which means we have 600 left. We're going to split it in two, which means that each of these lengths would have to be 300. So I'm going to have the width is 200 feet and the length is 300 feet down here, and those are my dimensions. It doesn't ask what the area is, it just says what are the dimensions of the largest such enclosure. You could do this a lot of different ways and get different areas, but if you're trying to get the maximum amount of actual space inside, especially if this is for animals.
So there's a lot of logic behind this.
Uh-huh.
Yeah, I guess it's...
So there's a process. There's definitely a process to it.
Because you have to think about it.
Mm-hmm.
Having it.
Okay, so we're going to do one more example. 11. And this is going to go a little further than I'll expect you guys to do on the test, but you could be asked to do parts of this on the SAT. This could be a college algebra thing, so I always like to at least expose you. So it says you run a canoe rental business in a small river in Ohio. Just pretend it's in Lake City. You have a canoe rental business. You currently charge $12 per canoe and average 36 rentals a day. An industry journal says that for every 50-cent increase in rental price, the average business can expect to lose 2 rentals a day. Use this information to attempt to maximize your income. What should you charge? So if we think about pricing things, your price is your independent variable because you have control over that. You can make the price whatever you want. But then your rentals are going to, your rentals are going to depend on what you're charging, and your income is based on that. So there's sort of a 3-part thing. But if I make the price go up for a little while, I keep making more and more money until you get to this price where people don't want to pay as much, and then it's going to come back down. And so there's this perfect price in the middle somewhere where you're going to make the most money. It's income and price.
Income.
Sorry, I was trying to write up and it didn't work. So there's a maximum price that you can charge to get your income. But it's a little bit complicated because we have to look at the rental price, how many rentals you're getting, etc. So
real quick,
yes.
Number 9, for what we did for that is for the little point, that's the vertex. Is max and vertex.
Yes, maximum or minimum, you find the vertex.
Okay.
Yes. So, and that applies to this as well. So your income, the money that you get in, is how much you're charging, the price, times the number of people who actually pay the price, which would, in this case would be our rentals, right? So that's how you get how much income you have in simple terms. Now, I'm going to use I for income, and I'm going to make price X, okay? So price is going to be X, and we know a little bit about that. So right now, my price is $12, and we know by reading an industry journal, so probably a journal on renting sports equipment type stuff, skis, canoes, kayaks, that sort of thing. It says that for every 50-cent increase in rental price, the average business can expect to lose 2 rentals a day. So I'm going to take my price and pretend that I'm adding X number of 50-cent increases. So this is price increases, I guess is what I should call it. Price increases.
How did you get 0.5?
So because it's a 50-cent increase in rental price.
Oh, okay.
So I'm increasing my price 50 cents X number of times. And then my rentals, if I do that, if I'm increasing it 50 cents per rental, it says right now I'm getting about 36, But if I increase the price, I'm going to lose 2 for every one of those 50-cent increases. So this is 50, I should write it out a little differently. This is 50-cent price increases. Sorry, I had to wrap my brain around the whole thing. So this part is representing my price that I'm charging with 50-cent increases built in, but we don't know how many. And this is giving me how many people I'm going to lose if I increase the price. And all together, we can kind of come up with the maximum. So we're going to use FOIL method to multiply this out. So 12 times 36 is 432. 12 times minus 2x is minus 24x. 0.5x times 36 is 18x. And 0.5 times negative 2 is negative 1x. Oh, and x times x is x squared. And then we want to combine like terms and put this into the order that we're used to working at. So if we're putting it in order, though, what would we want first?
X, negative x.
The negative x squared. And then my x is in the middle, so negative 24 and positive 18.
Negative 6x.
So negative 6x, and then plus 432. So this is the curve that we're looking at. If I can find the vertex of this parabola, that's going to give me the price that I should charge, and it will tell me how much money I would make off of those canoes. This is probably not the only income these people have, because probably they're selling canoes and other things. This would just be one thing that they're doing. Okay, so to find the vertex, the x part is always negative b over 2a. So negative 6 makes this positive 6. And then 2 times negative 1 gives me 6 over negative 2, which is negative 3. I'll put the negative on there. That way you know where the positive 6 came from. So instead of going up rentals, we got negative 3. So what this actually means is that you should reduce by 50 cents 3 times, which would be $1.50. I should actually decrease the price to make more money. So let's see how much money we would make if I do that. So if I put negative 3 back into my income, I would have negative 3 squared minus 6 times negative 3 plus 432. And I just put this into a calculator, and it comes out...
Hold on.
Hang on, I don't know that I did that right.
Okay, so should we work it out? Because negative for the negative 3 is the positive and it squares becomes 9. And then we would have to do that. So that's 9 plus...
So this would be negative 9.
Negative 9, sorry.
Plus 18 plus 432. I'm just looking at my notes, and I had actually... Oh,
so
that's... Well, we'll go with this. Okay. So if I put all of that together, what am I going to get? So it's going to end up being...
41?
Yeah, that sounds right. So $441. Let's figure out how much they were making before, just because I think that would be interesting. So I know this is intense. Like I said, I probably won't test you on this, but you could see this potentially somewhere else, and so I'm talking you through it.
With this one is that you're taking like the income, like almost every time, putting it back in.
Yeah. So we found actually. So right now we're charging $12 for each. But we're looking at 50-cent increases, except we want to decrease. So we're actually, this is if we charge, we go down $1.50, and it's actually $10.50 per rental. We'll make $441. Before, I don't have this written down, but I think it would be interesting. They had 36 rentals. And then we'll see if we're doing this right. Yeah, it's not a huge income. So before, they had 36 rentals, and they were charging $12 a day, and they're making $432. So this went up just a little bit, like $9. But if you did that for everything that you were renting, it would add up, and then that's every day. So over time, it would add up. This is not a very big rental place. If this were a bigger rental place, I'd have more than that many rentals. a day.
Yeah, I can see the real world application.